And please to confirm me. Hope you all can see my screen too as well. You can see my screen, right? Okay. I'm assuming that you were all able to see my screen. And then we
Sai,
confirm. Yeah, sure.
the English acceptor.
You can leave it. You can leave it. We will see it later. We will get into
Okay,
this.
okay.
Okay. Yeah. After
Okay.
this, we can look into that. Okay, fine. Okay, guys. Yeah. Today that we will just look into a Plaxis thing. Suppose now you have any kind of a problem statement that if you wanted to do a problem on that particular thing. Okay. For example, like as we all discussing about through the boards. So onto the settlement of a circular footing, I think really is well. Ashok, I'm muting. If you want anything, you can unmute and you can raise a question. Okay. Thank you. So moving on to the settlement of a circular footing over here. So now there is some kind of a problem statement. In the problem statement, it looks like this. So I just wanted to do a settlement of a circular footing on a sand. So it's a problem statement is very simple. Settlement of a circular footing. So that means the footing is in the shape of a circle and you want to see the settlements over a sand. Actually, this is what is actually the problem is telling that. So if someone asks you this kind of a question, like you have to do the settlement of a footing, then what exactly you can do? Yeah. So what exactly you can do is like, so you have to think about like what kind of a problem actually it is. So what are the minimum basic things that I need it actually to do this particular problem? What are the minimum basic things I need it? And Plaxis also supports you in the same way actually. So it will help you to question the persons in the right way if you know the Plaxis usage also. So how it is going to be. I know only a one particular thing called as a settlement of a circular footing on a sand. Now, the first thing you will rise up is like, okay, what is the geometry of your footing? You mentioned it's a circular one. What is the diameter of this? And what is the height of this particular footing? Okay. On a sand that you are going to put this particular foundation. So now you just need to know about the properties of your sand is must and should. So this is a very simple statement. That's why you could able to identify that. Okay. Once you just go into the deeper dive into this. So how you are going to handle that situation is like, this is how we can able to do that. Now I have a soil. Over to that soil, I'm just going for a structures and structures to a meshing to flow conditions and flow conditions to a stage construction is what actually I'm going to do. So if you just go here, guys, in our wiki, if you just go this, let me duplicate this page. And you just go to our wiki. Okay, if you just go for this particular thing, Plaxis presentation in February 2022, we have this Plaxis presentation. Yeah. So in this, if you just go here, we have a something called as an Plaxis overview presentation. So if you just download this particular presentation, if you click on this, that will download to your local machine. So you can just go and open this. Sorry. So now I'm just opening this. This particular presentations will guide you like how you can able to go through that particular questioning and all. How you are going to question that when you need something. My goodness, that was not here. Okay, this is not the one. Then, okay, might be it's not there. I'll try to list out that particular slide and then I can give it to you guys actually. So we can do that actually. So how we are going to do that is like, so there are cases like I'm just going for a soil, structures, mesh, flow conditions, and as well as the stage constructions, right? So when you just go for these kind of things, you can just go here. So now I have something called like the first one is called as a soils. And if I just go followed with that, I have something called as an geometry, and followed with geometry that what I need to ask is something called as an meshing, and followed with meshing that what I need to ask is something called as a flow conditions, and followed with flow conditions. This is very, very important. This is what we call it as a stage construction. So what we are going to do, if you just know for this particular problem, any particular problem, first of all, you should be remember this particular five things in your mind. So it should be like a soils, geometry, meshing, flow conditions, and as well as the stage construction. Either you are doing it in a Plaxis 2D or in a Plaxis 3D, whatever it may be, you have to remember of all those things. Either it is of a Plaxis 2D or 3D, you should be remembering this very much in detail. So once if you know this, then automatically the remaining all things can be done very, very easily. That is what is my intention. And that is what actually the software also follows it actually. So now if you are into the Plaxis 2D or 3D, so the first one it is like, for the time being, you just assume it as a 2D only. Don't be get into the 3D confusions. So now you're going into Plaxis 2D. Okay. Very first thing actually, before getting into this particular thing, so maybe I can just do one more thing. Is something called as project properties. So you should be remembering about something called as an project properties over here. So you should remember this. Guys, I'm just doing it in front of you guys so that you will be. Oh, my bad. So first of all, the moment that when you are trying to do this in Plaxis 2D, so for any problem that you need to understand about the project properties. So what you're going to see in project properties, when you just go for this, how to access this and what exactly it is. Why? If you just go here, there is a something called again project properties. If you click on this particular project properties, it will allow you to keep the title of your thing. So what it will say is that it will allow you to enter the title of your project, and then you have to go something called as a model, which is very, very important. So here actually in the model, it will ask you to select whether it is a plane stress problem or it's a plane strain problem. And I already discussed about this. The main reason that we are coming into the plane strain is like, as per the Moore column, plane stress cannot be helpful for us. And especially in Plaxis, any kind of a soil failure is especially categorized or especially derived based upon the Moore column failure criteria. So to get this particular Moore column failure criteria, we need these particular stress values are very. Okay, so that's the reason actually we will be choosing this particular plane strain problem. So if you just go through what is our first video of what is plane stress and plane strain, then you might be understanding that as well. So now this is a one plane strain problem. Yeah. And the other problem, if you see, this is called as an axis symmetric problem. So if you just click on this particular axis symmetric condition, what exactly it means? So if you just go for this an axis symmetry, what exactly it means? That is what actually you need to choose that. So that is what it is happening in the project properties. So project properties will help you to decide what kind of a geometry that you are working actually. So if you're working on this particular geometry, so what kind of a geometry that you are working, project properties will help you to choose this. It is a plane stress or it is an axis symmetric problem. So it helps you to decide this particular things and all. So it's all linked to your geometry conditions. So it's all links to your geometry only. Okay. So especially you should remember this. Sorry.
Plane strain you told me.
Plane strain is not acceptable in Plaxis because plane stress only supports in calculating the Mohr-Coulomb failure criteria. There is a no plane strain problems in Plaxis. We need to calculate the failure criteria, right? To look into that particular failure criteria, you should be a follow this particular things. Maybe if you can just look into my recent things, Plaxis intro. So in the Plaxis intro, I've just clearly told you this. This is what is actually the plane stress and plane strain problems. And then if you just look into this is what is actually the plane stress and plane strain problems is that. So if you are looking for something, so this is what is actually that you are looking over here. So if you're just looking into this particular plane stress, 1 second, just give me a minute. Sorry, guys. Yeah. So if you just look into this, I have something called as a plane stress and plane strain problem. So in the plane strain problem is what is, sorry, I mean to say that here I should be keeping this as a plane strain. Okay, that is what you are telling, right? Plane strain. Yeah. Maybe I have just typed it and typo error actually. It was actually the plane strain. And Plaxis supports only the plane strain or an axis symmetric model. Why? Because this is already a criteria that we have seen this. Because of this particular things, if you just look into this, Plaxis especially works based upon the Mohr-Coulomb failure criteria. If you just look into this particular Mohr-Coulomb failure criteria, so especially the Plaxis works on this particular failure criteria, where you need to be very much keen about this. Okay. Okay, that is fine. So that means in an assumption saying that if you are working on any of these particular 2D problems, it means that any problem comes under a, this means that any problem comes under a Mohr-Coulomb failure criteria and all the problems are like a plane strain problems. Is that assumption is true? No, actually. There are ways actually where apart from this of a plane strain problem, there is a one more model it is supporting for us that is called as an axis symmetric model. So what exactly an axis symmetric model says is like, suppose when you just go for this, I will just do one thing. So from here itself, we have something called as an axis symmetric conditions, right? So if you just want something like an axis symmetric condition, so how exactly it will represent is like, suppose when I select this here, the model, it has an axis symmetric condition. So you should be in a position to say that whether it is an axis symmetric model or not. So if I just choose this as an axis symmetric condition, so oh, I've closed this presentation to inspire. Okay, now if you just guys look into this, here I'm putting this as an axis symmetric problem. And whereas the other problem, if I see here, I'm just calling it as a plane strain problem. So why? Especially whenever I see in a title, if there is something called as in circular objects are there. So you have to just go and look into this. When you just look into this in the geometrical wise, if your geometry is something says, if your geometry is something says it is a circular objects, if your geometry says it is a circular objects, then actually it falls under the axis symmetric conditions. So this is where actually this is called as an axis symmetric problems. Actually, we call it as an axis symmetric problem. So whenever you should be in a position to know that, suppose if you are doing in a Plaxis 2D, and if you in the project properties, if you're going it as an axis symmetry as a selection that, and this is an axis symmetry as a selections, then actually from the geometry that you should be having an input that is called as in circular objects, and from the problem statement also, that's when both the arrows I just kept it. So if it is a circular objects, then we are going to call this as an axis symmetric conditions and all. If it is an axis symmetric conditions, the other modules and all will not be unapplicable for that. So we can just delete that. So if it is a plane strain problem, it goes on this way. If you are selecting, if you are doing it any other problem apart from your circular object, remember in this particular way, if you are doing any problem that if your geometry is not involving any of the circular objects, it's either one geometry is involving circular and the other geometry is a planar, also it should fall under axis symmetric model only. Any geometry is having a circular object, even one geometry, even one geometry is also having a circular objects, then you have to call it as a axis symmetric conditions. And all. That is what actually you're doing it in a project properties. So that is what actually you're doing it in project properties. The project properties works with two things. One is called as an plane strain. Other one is called as an axis symmetric model. Axis symmetric model, when I'm going to call, when you have any kind of a circular objects, then you are going to call it as an axis symmetric model. For example, let's say that I have something called as an, I'm just showing you one image actually. So I have just something like an image or like a soil polygon that I'm just doing it over here. So about this particular plane, so about this particular plane, I'm just drawing this particular polygon. About this particular plane, I'm just drawing this particular polygon. And in this particular plane, if I choose this in the properties, file, project properties, and in the model, if I just choose this as an axis symmetric condition, okay. Then if you just go for the structures, then actually software, what it will understand is like, this is a circular object. This is a circular object. That means whenever you just look into the top view of it. So whenever you just look into them, this is a top view. If you just look into the top view, this looks to be a circular object. And if you just look into the front view, actually, it looks to be a rectangle or something. Okay, whenever you just look into this, these are the objects that I'm just going to call it as a my. These are the objects that I'm just going to call it as my circular objects. Now I hope like you all got it like. So what do you mean by an axis symmetric condition? So an axis symmetric condition says that actually if you have a circular objects in any of these things, and if any of the object in the top view, when you are looking for that particular geometry, it looks to be like a little circle. then or and the front view that if you're just this is like you can say that okay, you can say that this is the front view of this particular object. So when you're just looking into these kind of things, so this is a circular objects, even one geometry, if it looks in the top view and the front view, it looks like this. And it is all like, all the remaining views like isometric views or like the sectional views, whatever you see that. If it is a circular object or not a circular object, easily you can able to identify that. Yeah. Now the question comes to you like, Sai, actually, when you just look into that particular problem, there are so many piles that I'm using it, which are all like a circular piles that I'm just inserting into my soils. Do I need to consider that particular problems as an axisymmetric problems? No, that is where actually in our first session that we have discussed one thing that's called geometries. If you just look into this, that is where actually the geometries I'm telling that. So whenever you just see this one, how you are going to decide this particular object is actually a plane strain problem and it has to be in a circular things and all. So in that particular cases that you have to decide in this particular way like this. So what is your thing is based upon condition is this actually. So you have to follow this particular conditions. So the conditions that you are following is something like 1D, that is a line element. So when I will call it as a line element is like when X is too large when compared with Y and Z. So in this particular cases, I will consider this as my, in this particular cases, I can consider this as a 1D element. So now if I just see these particular things, these are nothing but your beams and columns. Okay, these are nothing but your beams and columns actually. When you're just looking to this 1D, these are like when X direction is too large, that means length is too large when compared with diameter and as well as the width of it. So, okay, so in that particular cases, actually, you have to consider this as a 1D element. So all our piles are going to be considered as a 1D element. And when you are going to consider it as a 2D is something like X and Y are 2 greater than Z, or the other condition is like X and Y are 2 less than Z. So if I have a 20 meters, I mean, if I have some 2 to 3 kilometers of embankment, where I would be considering this only a plane of that particular embankment, and then I'm going to do that. That's where I can consider it as a 2D. And if I have something called as an retention wall, retaining walls, I have it. Like I wanted to build some kind of a sheet piles. So the sheet thickness is like very small when come very small here actually. Here, sorry, here it is actually sheet thickness. Z value is like very small when compared with X and Y. So in this particular cases, actually you have to consider this as a 2D. So this is where actually you are dividing this and then you are going for this particular object. So and then you are going to decide this way. So I hope you got an idea and please let me know if you are not able to understand what is an axis symmetric model. Do you have any questions? Feel free to raise your hand and ask me what is an axis symmetric model. And the moment in the project properties, if you select it as an axis symmetric model, what is happening? Yeah, yeah, Vivek.
See, if there is a structure curved on its ends, it will be considered as axis symmetrical.
Structure called on its ends.
Curved at ends.
Curved at ends.
Like a
Yeah,
like
it
a
can
like a
also be.
rectangle.
Yeah, it can also be considered it as an axis symmetric model. That is what I'm telling. So if you just look
Okay.
into this an object, Let me, I'm not a good drawer in this. If I, okay, say this is your axis. And over to this particular axis, actually, what you're trying to do is something from here, you're just going it. And one more line, you're just trying to bring this. Please consider that these are like connected with each other. And here, there is a something, one more curve kind of a thing that I have it. Let's say I have something over a line like this. And again, my curve again starts here and it ends here. And yeah, okay. Again, this, I'll just go here and then come here. And if you just consider this particular part over here to here, and then if you just consider in this particular way. Okay. So if you just consider this particular way, this is also an axis symmetric problem where I have a curves. So this revolves around this particular axis. We can consider the axis as the dotted lines. So that would make sense. So now this is your y-axis and this is your x-axis that is defining it. And the moment when you just go to the project properties and select this, this is going to be rotate in about this particular axis. This is going to be rotate. Now, when I just look into this particular top view, actually, it looks to be only circular one. And when I just go into the front view, only then it looks like this.
Okay, got it. Thank you.
Yeah. Yeah, that's good. I think we can move this to again. Yeah, we can move this to here itself. So now you got it. So when
Means
you are just
when even a single part of a circular figure can make a axis symmetrical figure.
yes. Okay.
Okay.
Now if you just see this one, when you go for a Plaxis 2D and in the project properties that it will ask you like whether you want to select it as a plane strain or an axis symmetric model. And if you want to select this as an axis symmetric model, the minimum things that from the geometry, there should be a circular objects in your geometry. And the circular objects for that, how do you are going to say that there is a condition? If it is only the piles kind of a thing, then we cannot consider that as an axis symmetric problem. Apart from piles in 2D, there are some these kind of conditions. If it is accepting, I can consider this as a circular objects. And then the views are also something looks like this. And then I will choose that as an axis symmetric problem. But if it is not something like this, I can simply go it as a plane strain problem, and then I can do this. Okay, what happens is like, what happens, I can show you this. It's very difficult to draw over there. I can just do it here itself. So when I just have something like this, now you have for a slope stability, you're doing like this. Okay, so the moment that when I select it as a plane strain problem, software will assume that it is in this direction. Software will assume that this is in this direction. But for the same thing, if you select it as an axis symmetric model, so this same thing, it will try to revolve about that particular axis. And when you see that the top view, actually, it looks to be something like this. Okay, you got it. What is a plane strain problem is doing? Plane strain is selecting in this particular way, and then axis symmetric problem is selecting in this particular way. Got it or any doubts you?
Got it. Got it.
Okay, fine. Let's go there. So geometry selections is very, very important actually, guys. So if you're just trying to do some kind of a slope stability analysis and by mistake, if you select it as an axisymmetric model, then all your problem is like mess up. So you will never end up with the right things and all. Okay. So this is where actually now you got a clear picture about this. So
One doubt.
any other doubts on this?
Yes, yes.
It's all clear, right? On the
No, no, no.
axisymmetric model?
Hello.
Bharat. Yeah, Bharat.
Ah, as you said, if we have one rectangular footing and one circular footing adjacent to each other,
Hmm.
then how can we model the rectangular footing in by assuming the axisymmetric condition?
See, in that particular cases, actually, Plaxis 2D is not at all suggestible software.
Okay. That means in 3D we have to draw.
Yeah, in
Design.
3D, you have to go for this. Otherwise,
Okay.
suppose that's a good question actually you brought. If your company is having only Plaxis 2D and you're
Okay.
supposed to do only in 2D, how you will carry that? Okay. So now actually you just see this. Whatever be a footing to footing, there might be at least like 0.5 meters of gap, right?
Yes, sir.
Okay. So let's do it separately. What is happening if I do rectangular footing separately and what is happening if I do a circular footing separately, and observe the recordings of this and then try to merge the particular results in an Excel, and then you can able to check what is the exact output. But this is a method of approximation when you have a limitation. That's it. You have to do this particular analysis separately.
As you said, we are using the Plaxis 2D, na?
Hmm.
But that piles are coming under 1D elements.
Yeah, piles are coming under 1D element.
Even though those are 1D, we are assuming as 2D.
No. 1D elements is always 1D only. We are going to simply like piles is there, no piles. We are going to call it as a beam elements.
Okay.
The basic
But
geometries that we know, right? So if you look into this kinematics of machines, I think we have it. Form. So in that particular subject, they might have told you like how to decide this particular geometry. What is a 1D element, 2D element? If you have a piles, in a piles, that you have to do it as like a 1D. No, I wanted to still do it as a 2D. Then there is some kind of an approximation actually. So what is that kind of an approximation is like, let's say that, let me do it here itself. If the diagram comes good, I'll bring it here. So you have something, a foundation, or yeah, you have some foundation like this. You have something called as a foundation. And now onto this particular foundations, I would like to insert a line. So insert these particular piles actually. So I'm just inserting these particular piles. So these we are going to call it as a 1D elements, or the 1D elements that we are going to call it as a beam elements. So what is the advantage of considering this as a beam elements actually? So if you just go for this thing. Let me put something. Yeah. So what exactly I'm going to call it as a beam elements actually? What is the advantage of going this with the beam element is like, suppose beam element will support in getting the shear force and bending momentum diagram. Shear force diagram and bending momentum diagram can be able to capture it. In that case, yeah, not like this. I wanted to go it in 2D itself. So there is then disadvantage when you just go instead of considering this. If you consider that as a 2D itself, there is a disadvantage. What is that is like? Let's say that your width is this of your pile, you're fixing it up, and then you are extending this particular pile length. But to the software, what is the assumption it is going to make onto the third direction? The third direction assumption is something like this, right? It will just extend it in this particular way, and then it will extend in this particular way, right? Which is not correct. That means indirectly you are thinking. Please try to bring up your geometrical skills, the first year BTech, that whatever we have done. So I'm just trying to pull this. So it is a kind of a wall it is constructing inside this particular soil itself. But because of this, actually what happens, when you do this particular problem, the strength of the soil will increase a lot, which is not realistically correct. Which is not realistically correct. But in some cases, actually,
Hello.
Hello,
Hello.
not audible, sir.
Yes, yes. Hello.
Hello,
I think there might be some problem.
hey, I'm sorry all. There were some power fluctuations, so it took a while to restart my Wi-Fi. Yeah, I'm just sharing back my screen. Oh, please do confirm me if you all can able to see my screen.
Yeah, yeah.
Okay.
yes,
Thank
sir, able
you.
to see.
Yeah, thank you. Yeah, now when I just assume like this, that is going to be there, that is not the right one. So it's always preferable to do that particular kind of a foundations, because the footing, rectangular footing also you are considering that much width, and the pile is also considered, you are considering that much width. But if you just go for this particular things, there is a one advantage where you can able to consider this. And the other advantage is like here, helps you to provide the offset distance. That means to a pile to pile, what is the distance? That much, I mean, not this way. The third direction, what is the distance? That particular offset distance also you can able to give it. So that is one of the advantage that when you're just going for this. Okay, it's all like you have to do the problems. Yeah, sorry.
How can you define that as a one-dimensional problem or two-dimensional problem? Where we have to define it? The software itself assumes.
See, first of all, you have to take your assumption based upon your geometry. If your length is too large when compared with the other two dimensions, then you have to consider that as a 1D element. When you just go it as a 1D element, in software, all the 1D elements are going to form it as a beam elements.
Yeah, yeah. That's what I am asking.
Okay, so
Okay,
I'm just
okay.
going to go create this particular line or a beam, so you can able to go for this. Now, now you have to do this, right? So this is a 1D element. So now if you
Okay.
just want it, you can just go create whatever the one that you want it on. So now you wanted to make it as like an embedded beam row. That is where actually you're going to call it as a pile actually. So when you just click on this particular pile, so it will ask you all the other parameters like, so what is this? Behavior is a pile, connection is at the top end, and what kind of a connections that you are giving it. Suppose If the behavior is not a pile, we can consider it as a rock fault or a ground fault. But if you want to come to this particular position, first you should be able to identify that this is a 1D element, and that is your estimation. And when you just go for this particular things, there is an option here. You can able to create it. So what is the name of your material, Young's modulus, the Poisson's ratio, and what is the shape actually? It is a predefined shape. Then it is a massive circular beam or a circular tube or a massive square tube. So all the things that you have an assumptions. Or if it is not a predefined shape, if it is a user-defined one, then you have to provide the area, inertia, and the spacing between the piles also. Even if you go, it's a predefined thing, the spacing between the piles in the third direction. Let's say to a pile, I have something like around 1.5 meters of a distance. You are providing this. Okay, any kind of an assumption is having its own, it should have its own justifications also. We should not simply assume that. So for that, with all the things, I'm telling that whenever you look into the geometry, the very first case when you look into the geometry, and if it comes under a 1D element or not, you have to decide it just by looking into the length that you can able to trim down to the 1D element or not. Is that clear? Make sense?
Yeah. But you said the pile to pile distance along one longitudinal direction.
Yes.
If there are two rows of piles, then we have to do it in 3D.
What two rows of a piles means? I didn't get
That
you.
means there will be adjacent row of piles. In general, for compound wall
Okay.
only, we have one row of piles in general.
Yeah, this is adjacent only. No, now it is having a 3 rows of piles.
Yes, there will be another row behind in Z direction.
Okay, in
Then,
that particular way. Okay, you mean to say in this direction there is a one more row it is coming. No.
yes.
See,
In
when you
the-
just look into this, anything that you have to look into the top view first. See, I have to clear it bottling. You have to look into the top view. When I'm just looking into the top view, so the first thing actually you have to identify that the piles are in like which directions and all. So these are your piles. So you're going with one pile, second pile. This is your third pile. This is your fourth pile. Assume the geometries. When you make confident of your geometry, everything is very simple actually.
Okay.
Don't complicate it. Think that when your geometry is coming, try to view that in all the directions. Now tell me like what is missing it here. So the same thing I'm just representing in this particular way, saying that this pile to this pile distance is 1.5 meters. I'm just telling in my software. Okay, this pile to this pile I'm showing it over here. This can be happen it only for rectangular patterns or can be square patterns. If your things are like in a different way, like let's say you have something like this. You have a pile something like this, and you have a one more pile here, and you have a one more pile here. Then these patterns are called as a triangular patterns. These patterns are called as a triangular patterns. So when if it is a triangular pattern, then your Plaxis will not support you. Or if it is a user-defined pattern, now I will be creating a one more file over here, and I would be bringing a one more file over here. So for these kind of a things, actually, your Plaxis will not support. It's a user-defined pattern. So if it is a rectangular pattern or a square pattern, Plaxis 2D is supportable. And if it is of a user-defined pattern or your triangular patterns, then suggested to go with the Plaxis 3D.
Okay.
You look into any kind of a geometry and bring that and try to fit it in this algorithm. So you will just come to know this. Now this is the one, right? So on the top view, do you able to see the perfect view over here for this?
Yes.
Which is the patterns it is reflecting it. And to the front end, actually, you could not able to cover this particular informations. So that's why I kept it in a single box. To the top view, to the front view, I could able to cover the maximum informations. But here actually, when I just look into this, the very important thing when you are working inside any kind of, not only in Plaxis, when you're working in any kind of a 2D software, you are working on a plane actually. You are working on a blackboard. You are working on a plane. So please be remember that whatever the best that you can able to see over the plane, only those things you can able to reflect it here, not beyond that. Is that clear?
Yes.
Okay. So now moving on, actually, once if you just finalize it, which kind of a geometry that you are selecting it, it's an axisymmetric problem. Now to your problems that you can able to identify that. So which kind of a problem that we are selecting it, easily you can able to select for those particular things under. Okay. Now, once this thing is done, now I just need to go for my structures actually. So structures is nothing but here I'm just calling it as a geometry only. Okay. Sorry. Project properties. After that, next immediately the first one is called as in soils actually. So when you just wanted to define a soil, so what is the minimum thing that you wanted to know about this particular soil? So when you just really wanted to go with a soil, so the minimum thing that you should know about the soils is something like so when you're just looking into the soils, the first and last most that very important thing that you just wanted to understand is like information, like how many layers. Information, I'm just telling that that is nothing but your borehole information. So you're trying to collect the samples of your soil from your site using a borehole test. So you have to know about like borehole test information. And from the borehole test information, what you're going to get it like how many layers of a soil it was there. And the next is like individual layer properties. Along with that, one more important parameter is like what is the water level that you would like to consider this. So when you're just talking about your soils, the basic thing that you need to remember is like these are all the things that you need to remember. So the moment when I just go onto the soils, it will ask you start by using a borehole. So this is a borehole option. So click on this particular borehole and you can just go and select any way that you just wanted to choose. Okay, and later on, you're free to adjust those particular coordinates also. You're free to adjust those particular coordinates also. There is an accuracy. It depends upon the machine to a machine and to the grid size actually. This will change it, but don't worry. 2.6 e to the power of minus 18 is nothing but zero only. Okay. So, but still, if you're worrying about that, you have an option also just to choose it as snap to grid option. So just to choose this as a snap to grid option. Okay, I'm just deleting this particular borehole, this borehole. Now go here and you can just choose this. This is where like 0, 0 it is coming. Guys, remember this. If you are unable to pick the right position, always try to make sure that the snap to grid is switch on or off. If it is off, you could not able to pick the points. Now see this, if I just go and pick the point, it is like minus 0.02147. Okay. This switch is wrong, I feel, because again, I could not able to edit the values and all. So now I need to pick the value at the perfect position. So now you have to switch on this one, snap to grid. So when you just switch on this particular snap to grid option, click on this particular borehole and click it. then automatically you can able to see it's a 0, 0. Yeah, this is where actually I'm just telling that where exactly the locations of a borehole, you know that in a site where we are doing that. And what is the borehole information is like how many boreholes that we have it and how many soil layers that we have it for in each and every borehole. Okay, so just use this particular button called as an add. So it will keep adding you like how many number of soil layers that we wanted. You can go on add like n number of soil layers. So Plaxis can support you up to 250 soil layers. Okay, I think no other projects will use not more than that. So basically, I hardly see that. In my experience, I have seen about like 9 soil layers is the max I have seen. In some cases, 9 or 11. I could not able to remember it. That is that too for road and laying up the roads and all actually. So the road aspect layer itself will comes with 5 different layers, and the remaining things it will. Okay, so for that actually I've seen some 11. But maybe if in your experience, if you come across more than that also, it's good. It will allow you to feed that. So what is this? Soil layer 1 that I wanted to start from 0. And I'm going in negative directions because I'm going the depth wise, right? So that's why up to like -2, I see one particular soil. And from -3 to -4, I have seen a different soil. And -4 to -6, I have it, or -9, I have seen a different soil, or -9 to -15, I have seen a different soil layers. So this is where actually the moment that when you click on these values, now you can see that it is all keep getting updated like this. Okay, so the moment that when you just enter this borehole information, that is what actually the borehole information, how many number of soil layers that you wanted. So this is where actually that you could able to bring this. Next is like is it provide you only a one particular borehole? No, it can allow you to insert n number of boreholes. It will allows you to insert n number of boreholes. Again, this is also some kind of a limitations. If you cross more than 150 boreholes, the software will get hang sometimes, and there might be a chances that it will not solve the problems so accurately. So please be make sure about that how you are going to. But the option to add like more number of boreholes is like you can just click on this option called as a boreholes over here, and then click add at which position that you would like to add. Now the first borehole is at 0. Now the second borehole I would like to add it at 2 meters. From that particular 0, 2 meters distance I wanted to do, which is in the X direction. Okay. Now you see this is the second borehole option at band. Now in the second borehole that you see that the first layer is something around like only 1.5. And the second layer I see up to like -6. And the third layer I see up to like -12. And this is the fifth layer. So this will also gives you an option that soil, you can go with n number of a borehole and you can able to control your soil thicknesses at different boreholes also. You can able to control that. And the next is like at an each and every borehole that we need to show what is the water level content. To show that particular water level content, now you are showing in a borehole 2, right? So at a borehole 2, maybe the water level content is something like -4. You can consider this. Now this is going to show that. Now if it is like borehole 2, this is how actually it looks. If I just click on that particular icon, then it will allow me to enter the water in multiple cases. So now it is like at borehole 2, I wanted something like at -2 is my water level conditions. Okay, now see this thing. So now you can able to enter the boreholes informations, and you can able to do this, and you can able to assign the number of soil layers that as per your wish. So do you have any questions? This is the very first basic step that we need to go for the soils. When we are just going for the soils, you have to add these particular boreholes information. So when you are just looking into any kind of a problem, you should be knowing about the materials also, guys. Okay. Because on that soil layer which I'm adding it, I should be in a position to know that So now if you just go for the so now this is where actually the information that you are capturing. The borehole information is like what is the water level, what is the position of a borehole, and how many layers of a soil that you are trying to build it, and what is the water level of it. And individual layer properties also, that is where like you are defining it here. Soil material properties and the length wise also you could able to, depth wise also you can able to vary these properties. N number of boreholes, you can show it. We can show the N number of boreholes also. Okay, like for example, I've shown you 2 boreholes, but in the same way that you can able to build N number of boreholes over there. Any doubts as of now in this? For creating a borehole, after selecting all your model parameters, I yet to need to come for some few options in the model parameters, but I'll come back to that slowly. Yeah, yeah. In this, if any doubt, we can discuss. Can I consider that is all good?
Yes.
Fine there. Yeah.
Sir, excuse
Now,
me.
yeah, sure. Yeah.
First, we have to model a structure, then we have to put the borehole data.
No. First, you have to put the borehole data and then you have to model the structure.
Okay, okay, okay.
See, the moment that when you are putting this borehole information of the soil layers, back and the structure is building automatically.
Okay, yes, yes, yes.
So if you just want it, I can just take this image also. Can just put it here. Okay, so normally I use this as of my rough book kind of a thing to explain all the things. As we don't have the blackboard over here, I will be doing this, and this particular images also will be shared with you. Hope this is fine with you, right?
Yeah. Yeah.
Oh, fine. Okay, so if you're clear with the borehole options, here I would like to take a pause. If you feel it is not boring, we can continue. Otherwise, we can do it again on Wednesday. It's your choice.
No, please
Sir,
continue.
where I can get the link for the materials you have shown earlier in the presentation?
Uh, it is, if you just go to the overview, I've given you the link, right? This link already.
Yes, yes.
I haven't got this link right now.
Okay. Again, I'm just doing it. Maybe I can put it in. Where is that? Yeah. So I'm just giving the link again, so you can just go through it and you
Thank you.
can able to download that.
Yeah, got it.
I hope I have added
Thank you
you
so
to
much,
the
sir.
list. Yeah.
We'll
So
try and
what do you
get back
guys
to you.
think?
Overall,
Yeah, you can just go do it like
we'll
multiple
try for
boreholes.
overall.
Yeah,
Give some random properties and then see whether we'll be able to do at least ABC or only A.
yep, sure. Try it for your best, no
Thank you.
issues. Okay, come back to me and we can just look into all those things. No issues at all. Try.
Thank you,
If
sir.
that's good. I can stop recording too as well. 1 second.